So next up we have an interesting proof of concept, which code 1100 built regarding XML and blockchain by Lech Rzedzicki.
Yeah, that's right. Hey guys.
Please take it away.
Right, so this is combining XML and blockchain. So who of you have heard of Bitcoin? Has anyone not heard of Bitcoin? That's good. So as you know, Bitcoin is a cryptocurrency. The technology behind it is called blockchain, and another term for that is distributed ledger. So I'm going to use the terms interchangeably. Right. First, I'm going to talk about a little bit about fintech and a little bit about blockchain in financial technology and the hype around it. And first, the XML in finance. So it's not very marketed. You don't hear this in the news every day, but in finance, basically XML is everywhere. When you execute a financial transaction, like, I don't know, do a bank transfer or somebody buys a bond or whatever, there's usually XML behind the scenes happening. One particular use case that I am familiar with is regulatory reporting, where they use a standard called FPML to send the information to regulatory bodies. This is pretty useful to have a standard, obviously, and basically whenever a bank is exposed to a credit risk or sort of is out of pocket, in layman's terms, they have to report it. So they use XML. XML is obviously very stable by now. No one is thinking about doing XML 2.0, I hope. And it's really, you can just open an XML file in a text editor and still more or less see what's happening. So it's really working well. So I thought I will use XML for my sort of blockchain proof of concept and see if there's any problems with it. So this was my default basically. Now in finance, they have problems. You may have heard in the news. They're struggling with profits. The traditional business model doesn't really work. There's negative rates. It used to be that a bank could simply borrow money from a central bank, for example, or if there was a saver, get money from them, get a loan, give a loan to someone else, and make money that way. They still do. It's just they're making less and it costs them more. And one of the reasons is basically they're inefficient. Another reason is the regulation, because they have to report everything that they do, so they cannot cheat so much as they used to, and basically low yields. So if the base rate is like negative or zero, then they can only charge so much because everyone knows that the interbank rate is so low. Right. So basically they really need to do something about it because they've been making losses or the profits were not as expected, so that they're really struggling in this area and they're really desperate to do something. So yeah, I'm going in more detail about the bank regulations. You have to have capital requirements, but we don't have to dwell on that. Maybe the only thing I should mention that even if you're like a small tech company and you think you're not a bank, that regulation also applies to you. So there's a lot of new sort of tech companies that do quasi sort of financial services, and so far they've been getting away with no regulatory reporting or basically they have no such capability yet because they're a startup and they're doing MVP. So there's maybe an app that lets you send money to your friends using, I don't know, QR codes or something. And they're not reporting that, and they're basically in breach of the law. They just don't know it yet, and they haven't been, nobody's been after them just yet. So I think that they will need that sort of capability to report. Right, and I'm just going to quickly mention blockchain. So blockchain has been the answer for many of the financial institutions' ailments, and as a result there's been loads and loads of companies riding the hype wave of blockchain, and some of them are for payments, as you can see here, some of them for settlements or reporting. So Let's say there's a bond trade and you need to sort of report on that and have a record of that. And there's a whole class that I will, if I have time, I'll talk about the end, is the smart contracts, where the actual algorithm execution happens on a blockchain. That's an interesting use case, but I don't think we're quite there yet. So to sum up, banks need to reinvent themselves or make themselves more efficient, and actually implementing a better, quicker way to do regulatory reporting is a small step in the right direction, I think. Right, so quickly, a few more words about blockchain. So the previous presentation was a really good intro, because that bond you saw, there was actually a ledger of transactions. So that picture you saw in Abel's presentation was 400 years old or so. But actually there's older stuff from Mesopotamia, which is on clay tablets, and it's a ledger. It's not distributed because there's only one copy, and it was buried, so it wasn't very available. But still, it was a ledger. And the only thing with blockchain that's different is it's distributed and it's kind of digital. But actually, you can have copies, and I will show you that they're not actually on a computer. There's also Islamic records, which are first sort of attempts at proper double entry accounting, which we see today. Then Medici Bank in Venice, they actually introduced all the practices that we're kind of implementing in the 21st century. And finally, IBM actually first on like almost quasi machines that were mechanical, they were doing this processing where they had multiple invoices, or they had cash registers which already printed out receipts, but it was all mechanical. And now obviously we have computers and finally the enterprise solutions for the same problem, which is accounting and being accountable for what you've done, having a record that is not only like true, but somehow verifiable. Because if you just had a copy that you created yourself and had full control, then obviously you can make up things, and people still do. But obviously it's quite crucial. The bigger you are, the bigger the problem is if you lie about things. So actually blockchain, what it does allow is, because everyone has a copy, from a mathematical point of view, it's pretty much currently impossible to fake the data. What's happened? Right. So you know what Bitcoin is. Blockchain is the technology behind it. I've already said most of the things here. So it's literally that ledger of transactions in a chain. That's why it's called a chain. So there's transaction number 1, number 2, and they're connected to each other. And all participants have their own copy. And for example, in Bitcoin, everyone who has the blockchain, they have the whole length of it, which is, I can't remember, but probably something like 16 gigabytes or even more now. And it's growing, and it's going to continue growing. And as I said here, blockchains will store all of the transactions, so it's just going to keep growing, and you cannot delete stuff, which is good from a regulatory point of view. But it also means that for some things you don't want to put on a blockchain, like for example your name. If you want to change your name, it's probably not a good idea to put your name on a blockchain, because you can never ever change it again. And because everyone has a copy, generally it's not a good idea to store private stuff on the blockchain in a public sort of blockchain setup. Security is fairly standard, so the same what you see in public key infrastructure, public private keys, same hashing algorithms. The only thing that's different, it's done multiple times per block, and then every block refers to the previous block. So if you wanted to effectively fake a blockchain, you'd have to start from the very beginning of that blockchain. So in case of Bitcoin, several years now, and you'd have to basically fake every single block, and then you'd have to convince everyone on the network that your version is the true one. So that's why they call it the 51% attack, because you'd have to have more than half of the network to convince everyone, and even then they would probably notice. So yeah, I think it's the whole, there's a lot of repetition there. It's in some ways it's a little bit inefficient, but it makes it very, very secure. So that security means you can actually do money transfers like with Bitcoin. You can have a register of ownership. So a land register, I think, is a good example, or a driverless license maybe. Provenance is a pretty good one. So there is a startup that tries to do this by tracking the provenance of, let's say, coffee. Someone marks that coffee at the source, and then all the way through the supply chain. When you actually drink that coffee, you can go with your phone and see where it's been. There's always some problems with tracking physical goods, because you can detach the physical goods from the blockchain. But provided that it all sort of nobody is cheating, then it kind of works well in supply chain as well. But there are many wrong use cases. I don't think we're going to have much time to talk about them, but they're pretty bad ones. Someone proposed a blood bank to use blockchain implementation, so people would be basically using Bitcoin to pay for blood. It's just wrong. But anyway, let's.
So you mean it's wrong ethically, not wrong?
No, actually, it's wrong. It's wrong mathematically. It just doesn't make sense, because it doesn't save anybody, and what if the blood runs out? So yeah, right. So scalability is a big problem because you have to do all this math. I think you've seen some news about Bitcoin specifically. This is not a problem with blockchain per se, it's just a Bitcoin implementation. The block size is fairly small, so you have to, and it takes a lot of computing power nowadays to prove another block, so you can only fit so many transactions in a block. So it's a challenge, but it can be overcome. I mentioned privacy. Privacy is a big one, because like I said, if people have access to a copy, you cannot remove yourself. In EU, there's a law to forget, and it's just basically incompatible with blockchain. Smart contracts is both good and bad, because it's a good idea in theory, it's just the implementation is just not there yet. So guys, if anyone is interested, I'll be here like lunchtime, evening, you can talk to me, we can have some beers and talk about all these far-fetched cases, but this is not really, yeah. Now quickly about my implementation, so there's a bit of history. This guy is called Stoneman, he's in West Africa, he's like he believes in Illuminati, and he has this mathematical theory why 2 equals 2 and everything makes sense and how well it's connected. And he gave me some good ideas for an algorithm that is just slightly better than, well, in my humble opinion, it's slightly better than the original Bitcoin implementation. The stuff you see behind him, this is, by the way, Dalasi. This is Gambian money. This is about £10, I think. Yeah. This is a stone circle. So this is stones arranged in like a chain, kind of, you could say. They're 6,000 years old. They're a bit mystical, like Stonehenge, but less is known about them. Probably just foundations for the houses, but that's it. So I took all the terminology from that field trip. So the algorithm is called stone circle. The servers are called stone chain, and blocks I'm beginning to call them stones. Infrastructure, it runs on standard sort of cloud VMs. I'm running DigitalOcean, but obviously it can run any sort of Linux or AWS, whatever. Oracle, I was trying to mimic the environment that banks have, so a little bit backwards, old stuff, but proven and tested, and enterprise. I've used MarkLogic 8 because it's an enterprise database, and it provides many of the features I needed for a blockchain implementation in it. So the minimum deployment is just a single server. It wouldn't make sense because you're only proving this to yourself, but it's going to run. So I've done a minimum sensible implementation, which is 3 nodes. So if, for example, one node went rogue, the 2 would overcome the 3rd one. But you can have as many as you want. So cryptography, as I was saying, by default is the same algorithms, but you can adjust depending on whether you want more sort of security or faster execution time. So in this banking scenario, it's very likely that the players are going to be the bank, the regulatory body, and maybe the clients will want to actually verify the transaction themselves. But it's going to be a fairly closed systems, and I think even the clients will just verify read-only and not actually sign the transactions. So because it's going to be behind a wall, it might be worthwhile to have a slightly different setup than just Bitcoin. So I made it possible to adjust things. I've disabled coin mining. So in a Bitcoin implementation, you have to gratify people for doing all this hashing and signing the block with cryptography. You give them coins, which in case of Bitcoin are worth quite a lot. In a bank, they have to do this by regulatory reasons, so they will not get a reward. So I disabled that. So this ethnographic research I was telling you about, and I use standard database for storage, so it's pretty reliable. You can have backups, it has failovers, it has clusters. This is a very simple block in XML. Basically, this is a calculated hash after all this algorithm has churned through for this block. The prev is obviously previous. The genesis means it was the first block. And a block can have one to many files in it. So my idea of this is that if you have a transaction, that transaction generates an FPML XML document which has all the details about it. I hash that document, and this is that hash, actually. It's just a standard, like I said, SHA hash. And in a block, just like in a Bitcoin, you can have 1 or maybe 100 files. Currently, because it's just a proof of concept, I made it 1 file per block to keep it brief. But in Bitcoin, you have 1 megabyte worth of transactions per block, just to keep it a little bit more efficient. And then in that block, every 2 files are hashed together, and this hash is hashed with another hash, and so on and so forth. The algorithm is called Merkle tree, and if I had more files here, it would be doing the same here. So I've already implemented that, but just to keep it brief, it's 1 file per hash for now. You've got the time, you can have the public key, and this is the chain. So as you saw, this was just a single block, and it has this long red number here. And the whole chain is also an XML file, actually. So you have got the block. This is the genesis block, so the first block. The second one is, as you can see, the number is the same as you saw in the block. And 1, 2, 3, and 4. So by having both individual blocks separately and then a chain of blocks, you can very efficiently look up a given block or a given hash. But basically, this file, this chain .xml, is what you want to distribute between the different nodes, so they all have a copy. And if anyone wants to add something, I have a little consensus algorithm to agree that it's fine to add another entry in that chain. So it's a very simplistic implementation, but obviously here you can just add many more fields. It's XML, it's extensible, so you can add stuff like some metadata, maybe what type of a transaction that is, maybe we've only got an ID for the user, but we may have one for organization and a user, etc., etc. So it's all extensible. So this is roughly the implementation. So I've got some screenshots here for uploading, but I will attempt a live demo now. So guys, this is the basic interface. It's, again, very simplistic. So like I said, whenever you say buy a bond, it generates an XML file. And then we're gonna go to samples, not this one. So we've got some FPML samples here, and I probably used up all of these already. And let's say someone bought a bond. This generated a FPML file that has info about who bought it. I will show you how it roughly looks like. So this is the FPML. There's a lot of info, and we're not gonna have enough time to go what's in here, but it's basically who bought what from the parties involved, the amount of money, and basically all the details about it, the terms of the contract roughly. That's what's in the file, and then I'm going to upload that file, right? So you can see it's here. I'm going to click upload, and this is going to generate hopefully a hash of the file. Right? Am I on Wi-Fi? I wonder. A hash of a file. Can't see whether I'm on Wi-Fi or not. Help is it's working? Yeah, we're working. So, so as with live demos, there's what's happening. Actually, I'm going to reload that because it's been there for like 24 hours. So I'm going to upload FPML one more time. So basically, there's two states that can happen. It can either say, it's fine, this is your hash, there we go. This is your hash, the resolution is not great, and this is the newly created block. They're two separate things. So let's say if we had hundreds of transactions per block, you wouldn't always get the new block. But with this hash, basically this is your proof that you have uploaded the file. So if a bank did publish this to the network of Stone Circle, that the regulatory body was also on, this would be a definitive proof that they published this, that they have complied with the regulatory requirements of publishing the report about the transaction. So with this hash in hand, they have a solid proof that this was published to the network, and even if it takes like a millisecond later to reach the other nodes to distribute, they can, at any point in time, they can prove that they've done what they were required, or the regulatory body can check that they have done so. So let's verify this now. So I'm going to verify by hash first. So this is the hash I got, and I'm going to click verify. Why this resolution is so low? Sorry. I may have to quickly change the resolution or just make this smaller. Yeah, this should work. So I'm going to verify by hash one more time. Yeah, can you see? So file exists and it was created, and we can obviously extract more details just by looking up the hash in the database. But the thing is that if we had 1,000 nodes on the network, they could verify on their own copy. They could get the consensus that all the copies are in sync, and that it would work. There's also, let's try and upload that same file again. I'm not sure which one was that. Let's start with this one. So this one already exists, as you can see. So it's preventing me from doing this. A few more things I've implemented, that it's actually running schematron verification. So if this was not a valid FPML file, it wouldn't let you upload. Because as I was saying earlier, once you put something on the blockchain, it just stays there forever. So if you put garbage on, it will be there for everyone to see. So the only way to fix it would be to upload the similar file later, saying that this is an update to this one, but it's very cumbersome. So just so you know, the best way to use to use blockchain is to only put good data there. So let's verify by the same file. So let's say another body had the same file again, but from a different source. Maybe they got it from FTP. They can check just by running the same algorithm whether this file has been published. As you can see, it does exist and it was created. So it could be some other body that wasn't even online at that time. They could just re-upload the same file, run the same algorithm, get the same hash, and mathematically prove that what bank published 2 years ago was what they say they did. So in this particular scenario, it kind of works because it's a very specific scenario for verifying that the bank have published all the regulatory information that they should have. I'm also implementing QR codes, so you can sort of scan them. So with a bond like you saw in Abel's transaction or bonds in general, right now they're actually pieces of paper, or the paper money that you have in your pocket, which I don't. It's basically a promissory note. It used to be that you put gold in a bank, and the bank would promise you that if you ever came back, it would give you back the gold. So now it's like an empty promise almost, because it's still a note saying that this has value, but it's not backed by anything. So bonds or a transaction like this is very similar. So you can actually scan this QR code and it will give you back the proof that they've done what they've done. So basically 2 equals 2. It's pretty tricky that, you know, there's so much going on in the world of blockchain, but there's also a lot of hype and sort of lot of people who don't really understand this but do their own project with blockchain. I've seen people come to me and say, hey, what can blockchain do for us? And I said, do you actually have a problem? Or, you know, like they didn't. They just wanted to do something cool with blockchain. And I'm not really sure why there's this much hype about this. There's people, you know, doing land registry in Haiti. There are people, you know, doing some crazy virtual currency on top of or something else, but it's a lot of that is uninformed or ill-informed. They understand a little bit, but not all of it. So I did this proof just so I could be in a position to say, guys, you're doing this wrong or you're doing this right, because there's a lot of misinformation in this area. Right, so do we have time for questions?
We do.
Yeah, so... Go on. Yeah, Abba.
Yeah, I don't pretend to know too much about blockchain, but from what you've been telling, it sounds a lot how distributed version control systems work.
Exactly.
Is that a
Yeah, that was.
analogy, or do I?
Yes. So another name for blockchain is distributed ledger, and basically that's why I used a database for storage, because you're literally storing a copy everywhere, and the idea is eventual consistency. That's how it's implemented in Bitcoin, for example. So they think like blockchain is technically or conceptually revolutionary, but it's been in enterprise databases for 20, 30 years now. So that's not that revolutionary. I think what's new is the trust, that you distribute the trust as well, because everyone has a copy. You may not trust any individual, but because there's so many actors in Bitcoin, for example, that it would be very hard to convince them all to lie the same way. Yeah. Shall we first go to more questions? And if we have time, I'll mention smart contracts, because I forgot about that. Go on.
Yeah, I noticed that your chain was most recent first.
I think, yeah.
The blocks. Is that to deliberate? Is that to allow streaming, for example?
Yeah, to append. Exactly. So you can just append. So this is actually an XML representation of the chain, but for efficiency, I've also got a way to put it in binary, and then I literally just append to a file. I don't even sort of rewrite the whole thing. So
that's most recent last then. Whereas this is most
Yeah.
recent first.
Yeah, if you append it, it comes up in the end. And this is
yeah, so
at the beginning.
it's the sort of at the top. Like
It's the reverse, yeah.
I was trying to visualize that concept, but yes, that's exactly the idea. That
So
normally
what was
it's
it you were
right
going
on.
to go on, Tom?
No, you go ahead.
I was going to ask about smart contracts.
Yes, the smart contract. Sorry, guys. So this is like the next level, and this is the current hype. So just if anyone is interested in discussing more, it's the idea that you use blockchain not as just a storage, but as an execution environment. So you put your code, your algorithm on the blockchain, and it is executed on all those nodes on the blockchain, so to speak. It's a cool idea, because then you're sort of guaranteed that the code will execute even if like they shoot you or your computer is down. But I don't know if I want to be shot, you know, or it's very inefficient as well, because you have to do all this mining, all this proof of concept. One example is Ethereum, and on top of that, the distributed DAO, the distributed autonomic organization. So basically you have Ether that you can buy, which buys you some execution power on the blockchain, and then you can upload your smart contract to a blockchain. So here I'm just loading a hash, but this could be a bit of XSLT code that I really want to run. This could be an algorithm that if it's deferred, pay me money. And as long as it's on blockchain and some nodes have access to nodes that have access to bank accounts, this could execute automatically as long as the conditions are met. And the conditions would be verified not by a single body, but by consensus. So again, at least 51% of the nodes agreeing that the conditions have been met. So it's really good. There's some scenarios where it actually works. So for example, if you have search engine optimization and you pay someone for, for your keyword like XML London to appear on the first page of Google, you can easily verify whether this is the case or not. And if this condition is met, you pay him the money, and you can have that code running on a blockchain and execute automatically. So your laptop could be offline. You don't have to do a bank transfer. The guy's laptop can be offline, but the transaction will happen nevertheless because the network is online. So it's a little bit like internet, but I think it's a bit slow and it's early days and I'm not convinced yet, but maybe, I don't know. So that's smart contracts, yeah.
Okay, sounds good. Any further questions before coffee?
Yeah. Obviously, come and talk to me if you want. I'm all ears. Yeah?
Okay, thank you, Lech.
Right.